Yeah, so hello everyone. So welcome back to the session on your linked list concepts. So the last topic what we have in this is circular linked list, circular double linked list, sorry. And in this we were discussing actually about the different operations what we can perform. So in the previous session, we have discussed how to create a particular double linked list, circular double linked list. And at the same time, we also seen that how we can display the elements that are present in that particular linked list. And then we have seen different cases that are related to insertion operation, like how we can perform different operations related to insertion. In that, we have actually discussed only two cases, I guess, right? One is inserting in the beginning. And another case, what we have discussed is something like inserting in the ending part, because these are the two cases where you will be seeing the changes in the code. But whereas coming to inserting the elements in between means after a given node or before a particular given node will be same as what we have discussed in your double linked list. Okay, so that's the reason we did not discuss this particular case. That doesn't mean that that cases doesn't exist. They are existing, but whatever the code we might be discussing in the circular double linked list for inserting a node after a given particular node or before a given node will be the same what we had discussed in a double linked list. So that's why we did not concentrate much on this. Only thing we have focused on here is something called as inserting an element in the beginning and inserting the element in the end, because these are the two cases where there will be a modification in the code, and we have seen the modification to how we have to do it up in the previous session. Okay, in the previous video, if you don't have any about that, you people can just go through it. And today now in this particular session, we people are going to discuss about something called as deletion operation, same as we had discussed for your circular single linked list. The same way we are discussing here. So here deletion operation also we are going to discuss only the two cases, that is deleting an element from the beginning and deleting an element from the ending. So those are the two cases what we are going to discuss in this particular session. So if you ask me about deletion operation, we are going to, as I stated, that there will be only two cases we are going to discuss here: the deleting the first node and then deleting the last node. So let's discuss how exactly the first node from a circular double linked list can be deleted. Now let us consider this particular case. In this is the list what we have. Okay, so which consists of around, I guess, five elements we are having. So 1, 7, 3, 4, and 2. So there are total five elements that we are using here. And since it is a circular double link, you people can see that the last element, whatever is there, will consist of address of the first node, and the previous block of the first node will consist of address of the last node, whatever we are having. So now this time I wanted to delete this particular node, and I wanted to make this as a first node number 1. So how can we do it? So here, in order to do that, what is the first thing I had to do is, that if I wanted to delete this particular node, the address of this particular node is present in this particular last node, isn't it? So what I have to do initially is I should be able to access this particular node. So I should require here some pointer variable which can access this particular node. So definitely what I have to do, I have to use a pointer variable. So using a pointer variable, first it will be initialized to start, slowly it will be traversing, and I think you people know very well how to traverse it to the last element. So since I have to go to the last element here, so I'm not going to check the values, I'm going to check the address. So I think you people know how to do. While pointer next not equal to, yes, pointer next not equal to start. So that indicates the last node, isn't it? Because the last node consists of, let us suppose the address of this particular node is 100. So the same 100 will be present here. So while pointer next not equal to 100, that means it is stored in a variable start. So we are writing like that. So while pointer next is not equal to start. So what we have to do, keep on traversing it. How to traverse that very well, you people know, pointer equal to pointer next. So you will be keep on traversing it until you reach the last node. So when you reach here, this particular program terminates and you come out of it. And then you will perform the operation that need to be done in order to remove the first element, whatever is present here. So that you can see here. So we'll move the pointer to the last node. Now what we have to see do here is, if you take this particular diagram, you can see the pointer is pointing to the last node, and this is the node I wanted to delete. You people very well know, let us suppose the address of this is 100. Okay, just for understanding, 200, 300, 400, 500. Well, even I don't know what is the code exactly here is. Just with the help of a diagram, I'm just going to assume it. And later, let's see whether whatever I am assuming is correct or not. Okay. So what happens exactly here is I want to remove this node. What does that indicate? The last node should consist of address of this node, isn't it? This is node number 1 and this is node number 2. Now this node number 1, if I'm deleting it, this becomes the first node. So it means whatever the address is present here, what is the address that is present here? 200. This 200 should be pointed here because initially right now it is pointing to address number 100, what this particular block, but now this should be pointing 200. So how can I do it? That is what the question is. So it's very easy how to do it. The code is like pointer is pointing to the last node, and in the next block I need to do the modifications. Okay, so pointer next equal to, now what is the address I want here? 200. Now I don't have any variable, pointer variable, which is pointing to this particular node. So how can I access the address of this particular node? So I think you people can understand very easily here that this particular address 200 will be present in which particular block here. If you remember, the first node next block will consist of address 200, isn't it? And this is the address which I want, and it is present in this. Now can I access this particular node here? Is it possible? I guess start next, isn't it? So pointer next equal to, I can simply write it as start next. So what will happen? So rather I can use start here or I can use a temporary variable. That depends upon the situation, whatever we require. So here just I'm assuming for understanding purpose, I'm using start here. You can see pointer next equal to start next. So start next block consists of address 200. That 200 I'm placing in pointer next. So this is pointer next block. So here 200 is coming. So link is formed with till here. So this link has been damaged now. So that means I have just disconnected it. Now the question here is, that's fine. Okay, so this has been disconnected. But the problem here is that, what is the problem we are having here? So I guess the previous address of this particular node, the previous address of node number 2, now this becomes node number 1, means the previous address of this should consist of the address of the last node, that is this. So something like 600. Now that's 600, but here initially this particular node consists of address 100. But now this 100 should be replaced with something called the address called as 600. Now how to do that? That is again same question what we are exactly having here. How can I replace this 100 with 600? I don't have any point variable that is pointing to this. So how can I do it? Very simple, sir. Same way how the way we did it. So here what we can write is something like start next. Assume like this, start next means start next consists of 200. So you're right now in this particular block. Okay, that is node number 2. Now here start next, which block I want to access here? The previous block, right? So you people can write something like this, start next previous equal to, what is the address I want here? 600, and that 600 is the last node, and this last node can be accessed using the variable ptr because that consists of the address 600. So ptr, so start next previous equal to ptr. So your task is completed, I guess. So you people will be getting 600 here. So you got 200 here, you got 600 here. Now this is totally connected, disconnected. Now you have to free the space. Now you know that start will be pointing to the next node. Okay, so start should be pointing to the first node. So right now, what is the first node we have here? This 200 is the first node. So start equal to what we had to do so that I can get this 200. So usually I can say that start equal to start next. So automatically start will come up here, but there is a small lagging here. What is okay? So simply you can write start equal to start next. So start next consists of value of how much? 200. So automatically this start will be coming to this particular node. But the problem right now what is we are facing is, since start is a variable which with which we are able to access this particular node, this has been skipped. Have you seen it? This start has come up here as per this particular statement. Now I don't have any pointer variable with which I can access this particular node. When if I don't have a pointer variable for accessing this particular node, how can I free the space given to it? So whatever the 100 space is there, I am not able to free now. I don't know what to write as a give as a parameter in order to free this particular node. So that's the reason I was telling that we will be using something called as temporary variable. Okay, so let me show you so that it becomes easy for you people for understanding here how exactly it works. So this time, whatever I did with the start, same thing I'm going to do it, but only difference will be here that instead of start, you'll be writing temp. That's it. Remaining process same, and the temp will be pointing to the first node which we wanted to delete. Finally we will be freeing that particular pointer. So I guess let's see how exactly this particular thing comes. Oh, okay, fine, I think you got it. Yeah, so let's go to the dashboard. So we want to delete an element. So you can see here the node. Now, as I told you, which node I want to delete here? This is the node which I wanted to delete here. So initially I have taken a pointer variable here. You can see a struct node start pointer. So pointer equal to start. Well, apart from that, you can even take something called as temporary. Okay, you people can declare here something like int temp or something like that. Temporary, you'll be taking a temporary variable which will be consisting of the address of the first node. So what did I do? What did I tell you what we need to do in the beginning? So we need to move to the last node. What is the last node here? This one. So I need to go to this particular location. So initially pointer equal to start. Now while pointer next not equal to start, keep on moving or traverse until we reach the last point, because it is a circular double linked list here. So definitely the last node will consist of address of the first node. So the pointer will keep on moving from here to here to here, and then finally to this particular location, because next consists of 100. So this loop is completed and now you're coming to this particular here. So pointer next equal to start next. I think you people understood now what we are doing. Pointer next equal to start next. What is pointer next? This one. It actually consists of address of this particular node, but what I'm doing here, start next means start next block. So what is the address we have here? 200, because this is a node. So that is what he's saying. So pointer next. So what is pointer next? This one equal to start next. Start next. So what is start next we have here? Okay, let me erase this. So here we have address 100, 200, 300, 4, and this is finally 5. So it consists of 400 and this consists of 500. So 300, 400. And this will consist of 300, it will consist of 200, and this will be having address of 100. Now what I'm doing exactly, so what will this will have? 100, and this will be having something called as 500. Now what I'm doing, pointer next equal to start next. So pointer next in the sense this particular box equal to start next. What is the address we have in the start next? 200. So that 200 I am assigning to this. So what will happen? So I am simply erasing this, and here I'm writing something called as, what is that? 200. So the link is formed here with this. Same way I had to, what after this, what I am doing before performing any other operation, I need one more temporary variable. I need a variable called temp, which I can access this particular node once it is detached. You have seen that in the previous one when I explained in the PPT presentation, you have seen that we don't have any variable that is pointing to the node when it is detached, and so we are not able to free the memory. For that sake, we are executing this particular statement. What is that? Temp equal to start. So initial temp is 100. So right now the temp is at present at this particular location. Now the remaining process is same. Start next. So what I have to change here, I need to change this particular 100, isn't it? I need to change this particular variable here. So how can I do? Start equal to start next means initially start will be pointing. So here he has used a different logic, like start equal to start next. What he's doing exactly here is, first thing, he is trying to jump this particular element. I mean this particular start, whatever you're saying, he's trying to make this jump to come to this particular location. How can we do that? Start equal to start next. Start next consists of 100. So when you're writing start equal to start next. So simply the start is jumping to this particular location. Now what I modify means this 100 should be modified. How can I modify? Equal to pointer, because pointer is pointing to the last node. So start previous equal to pointer. So pointer consists of address 500, and that 500 will be stored here. So a link is formed from here to here and here to here. This is detached now. Now what we have to do, since this particular thing is detached, we don't have anything similar to that, except that it is been represented with something called as temporary variable. Now we don't have this one. Start is pointing to this particular. Now this is the starting point. Start is pointing to this. So we have totally detached it. Now I have to free the memory that is associated with this particular node. How can I do? Since I have used a variable temporary here, so with the help of a temp, I can simply eliminate that, or I can simply free the space that ever is allocated to this particular node. And finally, you'll be storing the returning the starting position. What is the starting position we have here? This is the starting position. So this time start will consist of address 200, not 100, because this particular thing has been eliminated from this particular location. Okay, it's very easy. Let me explain one more time so that it becomes easy for you people to understand. First thing what you have to do is you have to take a pointer, and this pointer you have to traverse until you're reaching here, this particular location. Okay, now what you have to do, pointer next consists of, what is a pointer next? Actually, you can directly write this statement also in the beginning itself. Let temp equal to start. Let us suppose I'm writing this in the first statement. Temp equal to start, no big deal. After that, pointer next block should consist of address of this particular node, that is whatever 200. And you know that this 200 will be stored in this particular location in the first node. So that is start next. So what you have to write, pointer next equal to, so pointer next equal to, what if we can write here, start next. So whatever the address that is present in the next block, that is 200, will come here, and a link will be formed with this. Now what you can do, this start what is pointing here, you will be skipping this start to the first. You will be making that start variable jump to the next node, whatever it is having. How can we do that? Start equal to start next, because in the next block of the start consists of the address of the next node. If you see here, what is the address we want here? 200. So start next consists of address 200. That 200 I'm assigning to start. So simply start has come here, it has been eliminated. So if now what I want here, this address should be filled here, the previous address. Now this is the first node and start is pointing to the first node, so the previous address of this particular start variable should point to the last node. So how can I get that? Start the previous address, right? So start previous. It should get the address of what? The last node, because this is the first node. So what I have to write? The last node is actually referred with the variable pointer, PTR. So I'm simply writing pointer. So whatever the address is there, that I'm storing here. So that will be stored here and this will be detached. So finally, this node I can access using a variable called as temp. So now I will free the memory that whatever we are having here. So free temp, your task is completed. So that particular node, the first node has been deleted. Okay, I hope you understood how exactly this particular thing works. This algorithm, you people can just go through it. You know that when we are deleting it, we should make sure that there is no underflow condition, right? So for that purpose, we are using this start equal to null. If start is equal to null, what does that mean? There doesn't exist any element and you're trying to delete an element where there is no element. So definitely you have to simply print a statement that you're underflowing it, because there are no elements that are present in order to delete it. So you're still trying to do that. That means it's a underflow. Remaining process is same, whatever we have seen in this particular case. So the next thing what we have is deletion operation here. So deleting the last node. So same thing. How to delete the last node, same process we are going to follow here. First thing, we'll be having a pointer variable. That pointer variable, what we are going to do, so we'll move it first. Initially it points to the first node, then we'll make that traverse to the last node, and once it is reaching the last node, remaining process is very simple. And this is the algorithm here, and this I will explain it with the help of this particular diagram, this dashboard. It becomes easy. So what is this? What is a pointer variable we are using? Pointer. So initially pointer is at this particular location, and you know how to reach this last node, isn't it? So while pointer next not equal to start, pointer equal to pointer next. So what you are going to do? You'll simply skip from here. It will come here. So it will not be equal to start. You'll be coming here. Then you will be coming here, then here, and finally you have reached the destination where exactly you wanted to reach. Okay, so that is this particular location. Last one. Now I have to remove this particular node. Now what does that mean here? What are the changes I need to do here? So I have to make some two changes if I am not wrong. What is that? The first thing is the address in the next block of this particular node should consist of address of the first node. Same way, the previous this previous address, okay, of the first node should consist of address of this particular node. Then only I can detach this particular node. Then only I can do it, or else it's not possible. So how can I do it? So that is very, very simple. With the help of two steps, you people can do it. How? First, look into the diagram here. Now the pointer is pointing to the last node, and this is a node which I want to delete it. Then how can I access this node so that the next block should consist of, okay, let me write the addresses so that it becomes easy. 100, 200 here, 300, so 400, 500, and this is your 600, right? So this will be consisting of 600 here, and here it will be consisting of 500. So I'm writing here only because this is the one which I need to modify it. So that only I'm writing. Remaining is as usual. Here people are familiar right now. So here this will consist of address 600. Okay. Okay. I will write it on the onto the top. So this will consist of address here 600. You can see 600 means this node. And here what is the address we have in this particular node? We are having 100, 100. So this is the first node. Now I want to delete this node means the previous node, whatever this there to the last node, it consists of address 600 means this one. This should be replaced with the 100. That is nothing but start. So how can I do it? How can I get this particular next, I mean the next block of this particular node? How can I modify it? It's very simple. The pointer is pointing to the last node, right? So you want to change the address of this particular node. What is the address of this part? I mean the next block of this particular node. Now what is the address of this particular node we have here? 500. How can I access using this particular pointer variable? Can we access it with the help of a pointer variable? This particular node is possible. So I think you can understand the previous block consists of address 500. So I can access this particular block. How? Pointer previous. So this pointer previous will is pointing to address 500. So means you're coming to this particular node. And in this node, what I want is I want to modify the next block. So the next block I need to modify. Okay, that's fine. So what is the address I want here? The address of the first node, that is 600, should be replaced with 100. How can I do it? The 100 is present in a variable called as start. So simply I'm going to call it as start. So start consists of 100. Where I'm storing pointer previous. Where is pointer? Last node. Previous block consists of address 500. So you'll be jumping to this particular location. In this, the next block you are accessing. What is the next block? This one. So there you are storing the value 100. Initially the value is 600. Now you are overcoming this. And here you people are writing it as something called as 100. So there is a connection now. Connection from here, it is formed till here. That's very fine. So this part is completed. So this has been detached. Now this one is sorry, this part is detached. Now this part has to be removed. Okay. So how can I remove that? So here you can see the first node consists of address how much here? 600 means it is pointing to this node. But I want this node, this particular previous block of the first node point to this particular node. How can I do it? Simple. So start previous, I want to modify it, right? So this is a start, previous block should be modified. So start previous equal to, what I have to do? So I want the address of this particular node, this node. What is the address here? 500. I want that 500 in the start previous, not 600. How can I get it? If you see here, pointer next consists of the address 500. So pointer next. Sorry, pointer previous. The pointer previous consists of that. So if you see here, pointer previous consists of address 500 that I'm storing in start previous. Where is start? The previous value initially is having something called as 600. I'm going to replace that with 500. Your task is completed, isn't it? If you see here, this consists of the address of the first node, and this consists of address of this particular, means you have totally detached this particular node, and this particular node can be accessed using a variable pointer, and that is required because we have to free the memory that is allocated to this particular pointer. So free pointer. So with the help of 3 steps you are able to complete the entire task. This is the way how you are deleting the last element is going to perform. Okay, so I hope only this statement is something which you people have to remember. Pointer previous next equal to, remaining thing is almost the same. Okay, so I hope you people are getting it. How to do it? Simple. One more time I'll tell you. So pointer will be in the starting position, we will be traversing it, it will reach here. So I want to replace the address present in the next block of this particular node with the address start. How can I do it? So first I should be able to access this particular node. How can I access it? So pointer is pointing to the last node. So using pointer only I can access it. So pointer previous will consist of address of this particular node here. So pointer previous. So it will be coming to this particular node. In this, the next block I want to modify it. Next equal to, what is the address I want here? The starting address. Start. Done. That task is done. Now the start previous need to be modified and it should have the address of this particular node. So how can I do that? Start previous equal to, so pointer previous is the one which consists of address 500. So I will be simply writing it pointer previous. So what is pointer previous consists of 500? So I'll store here 500 in this. So automatically here it is 100 and here it is 500. So this part is completed. Now I have to simply remove the memory whatever is allocated to that. And how can I do that? Free pointer. That's it. So using these 3 code, you people can easily eliminate the last node, whatever is present in this particular circular linked list. So this is all what we have with respect to your circular linked list. And with this, we have actually completed your particular second unit. Okay. So this is all related to your linked list. All the concepts that are related to linked list have been explained here. Okay. And this is all for today's session, what we have. So thank you for watching this particular video.